This tutorial will show how to transfer colors from a LiDAR point cloud to a 3D mesh where both files were created in the free Cloud Compare software. This is the Cloud Compare software. It's got lots of features which I don't know how to use, so I can't tell you too much about it. And I'm going to give you everything I know as we go through this tutorial. So first we will open the LiDAR file, and we'll take this one, which has 7.1 million vertices in it. Now the point cloud is a long ways away from the origin and has small details. So the data can't be stored in a float, which is used for floating point numbers in Modo, Maya, VRML, and other files. And this one contains colors, so we want to use that, and we want to use everything's there, so we'll say apply. And here, because everything is far from the origin, we're asked if we want to subtract some numbers off so we can see everything properly displayed. So we'll say yes, and Cloud Compare remembers those values to put them on later. So here's our mesh, and it's to do the example faster. I'm going to take a segment of this file. So whenever you want to work on something, you have to first highlight what you want to work on, and then we'll go to Edit, Segment, and it brings us up Choices. And here we can either do a polygon selection or a rectangular section, and I'll use the rectangular. And I'll go here and select the top view, and this is the area that I'm interested in. So I'll take and click about here and then move out like so, and I'm interested in this area. I click here to say that I want to use this segment. Okay, there's the segment I want to use, and click the check mark for OK. So now I have a segment to work on, so I'll turn off the big one, and I have this one. Now there are two methods that I know of in here for turning the point cloud into a mesh. The one we get to with this highlighted, we go to Edit, and we go to Mesh, and we've got Delony, either XY plane or best fitting. I'm going to use this one, and I don't really know what goes on, so we'll select the default, and then it went ahead and did a triangulation. And so we have that. So now I'm going to take and save that. I'm going to click on the original file, and I'm going to click this button for saving, and it gives me a long name if I want to go ahead and save under that. So I'll take and save that to this file. That's the LiDAR point cloud. Now, so that I can match the vertices up between the LiDAR file and the 3D mesh file, we have to go out at the highest resolution. So I'll say OK, and that's saved. And then I'll click on this one. This is our mesh, and if I go to save, you'll see it wants to save it as a wavefront OBJ file. And what I'm going to do is I'm just going to simplify that down, and I'm going to call it Cliff 1. Okay, so, and I'll save that, and it's going ahead to save. Now the Delony can't, it has to do like it's looking down like just on the top of the model, so it can't do a model properly that has vertical faces. Now I'll go back and re-click on this, and now I'll go to plugins, and we've got Poisson surface reconstruction. I'll click on that, and this has different depths on it, which is how many vertices will be used in the model, and it usually comes up with a default of 8, but I'm going to go out and use 10, which will give us more triangles in the finished model. Click on advanced, and I don't know how to make exactly what these are doing, and you get 3 choices here for making the doing the Poisson reconstruction. I'm going to pick free and say OK, and now it's going to go ahead and do the reconstruction. Now when the Delaunay triangulation was done, it calculated normals to fit on the model, and if those normals weren't there when I went to do the Poisson reconstruction, it would have asked me if I wanted to calculate normals, and it would have given me 3 choices, and here's normals, compute, and there are 3 choices that you have for how you want to calculate the normals. Now we have new values calculated. A new point cloud was calculated based on the original one, and there are less vertices than would have been in the original model. The Delaunay uses all the vertices as is without making any adjustments. So I'll click on here, and I'll click save, and this allows me to save the object. And so I'm going to make this Cliff 2 and save that, and it's saving 1,233,170 triangles. And then I'm going to click on vertices to save to a new LiDAR file, and it's giving me a different name, and what I'm going to do is use the Cliff 2 name that I put on the mesh. Okay, we've got, and I want to again save at the highest resolution. Okay, so now if I rotate this around, you can see, okay, it's light and bright on both sides, and I'll turn this off and turn this off and turn this off, and we'll just look at just the, oh, just got to turn that back on. There is you can turn, okay, here we go. Now you can see it's dark on this side and light on this side. When you calculate normals, you have to make sure the light is shining on the right way, and if we go to display, we can go down to lights, and we can toggle the sun on and off with either the menu item or the F6 key. And when I do that, it's bright on both sides, so I'll turn the F6 back on, and it's dark on the other side. Now sometimes when you calculate normals, the dark will come on the wrong side, so if the dark had been up, I would have had to go to normals and invert the normals so the dark and light would flip around, so the Poisson reconstruction would have happened going in the right direction. So now we have our models. So I'll go to AccuTrans, and this is the original model. We started off with the 7.1 million vertices. Now to do the model, I go to Transfer LiDAR Color to Mesh. It brings this menu up, and I just click Browse, and I can go and I'll select the first one I did with the Delaunay triangulation, and I'll open that, and that name appears here. Now the name on the LiDAR file is different than this name, so I have to click on this button here, click on Browse, and this was the original segment that I cut out. And I'll say open, and I've got those. Now the mesh coming out of the Cloud Compare isn't oriented correctly to match up with the LiDAR point cloud. So I have to do a minus 90 rotation on the x-axis to get them to line up. And everything comes in its original vertices. And so to get it to display correctly in on the graphics card and in Moto, I want to I'll choose center on the XYZ. I could do any of these others if I wanted also. Sometimes the fast method for matching up the vertices from the two files will miss something, and so this default color will be used instead. And if you want to change the color, you just click on it and the normal Windows color picker comes up, and you could pick whatever color you wanted. Then when the transfer of colors is completed, the LiDAR point cloud is deleted, but if you wanted to keep it and have it display in AccuTrans, you could select that. Once you've got everything made, you click OK, and the file is being read, checking duplicate triangles, transferring colors, and here's our model. Now to save, I'll just click on the Option button. I've got Moto selected. The file, the mesh has both vertex normals and vertex colors. I don't want to save the normals, so I'll turn off that checkbox, but I want to save the vertex colors on the mesh, so I'll check that one and then click Save, and it comes up. AccuTrans is showing the name of the last file it read, and I don't want that, so I'll take that out and put in Cliff1 and save that file. Okay, that file's saved, and so I'll close that down and I'll select another work area, and we'll do the same and click there and select the second file, and as the last file has the same name, I'll click that off, leave everything else the same, go ahead, say OK, and now it's being converted. Okay, here we have this file, and I'll go ahead and bring this up. We'll keep all the same options, and I'll go ahead and I'll save that to cliff2.lxo, save, and it's being saved. Now we'll go back to the first one, and now if you come down here, you can see we've got a lot of jagged peaks and so forth, and that's because everything was used as is from the original model. What happens is, if you were making a map, the map makers would go in and they would remove any of these anomalies to smooth things out. And if we go over to the Poisson reconstruction one, you'll see none of those peaks are in there because they got removed by that method. And then the other thing it did on the free method, it took and it made the terrain actually larger than what it was in the original model. And now, just before we leave AccuTrans, I'm going to go and select VRML2, and I'm going to select vertex normals, output the vertex colors, and click Save, and we'll save that to the file, and we'll let that save. And now I'll go to Moto, and I'll do File, Open, and we'll take cliff2.lxo, open, And there's our mesh. And if I take and select vertex map, select the map, and there is our mesh with the vertex colors on. And when it renders, the vertex colors don't render in modal, so we just get the plain object. And if we take and select object under the render tree, and we click on this object, this comes up, and here's the white color. So if I took and I changed the color there, then the color changes in the render window. Now if we go back to AccuTrans, our model is saved. If we want a different color to appear in the render window, I could just click on this button here for adjust lights and materials, and go here. We only have the one layer. Select diffuse, click the Windows color picker, and then if I wanted it to appear green, brown in the render window, pick that color, click OK, and then when I save the file, it would appear in brown. Now I'm going to go to BS Contact, and I'll do a file open, and do a browse here, and we'll select the WRL file, do an open, do an OK, and now it'll take a little while to load. And there we are. There's our mesh with the vertex colors on, and we don't see any triangles because of I saved the vertex normals out, and there you go. So this concludes this tutorial. That's all you have to do to transfer colors from a LiDAR LAS file to a Wavefront OBJ file, where both files were completed, were done by the Cloud Compare software. Goodbye.